Welcome class to our Blue Notes lesson on Skill 6 from Unit 1B. The subject of this lesson will be on writing the equations to match given piecewise functions. On your outline you have the steps typed out here, so remember that you can always refer back to them when you are trying to do the homework. And you can also read them before the quiz to make sure you're prepared. But I will be going through each one as I walk through the examples as well, so you can also see what the meaning of these words are. So let's just begin with the first one. So you're given a graph of a function that's consisted of three parts. The first two parts are what we call segments, and this third part is what we call array. Your job will be to write the equation for the three lines and then give the restricted domains for each part. So the first thing you want to do is use what we call the piecewise notation. In fact, maybe what I'll do is kind of remind you of what that is. So proper piecewise notation is when typically we use this function notation f of x to represent the y value. And then we do this large one-sided bracket. And then there's an equation that we would write here for the first piece. And then we either say something like 4 or we write a comma. And then there's some sort of x inequality. So something less than x less than something, or maybe it's array. This would be if it's a segment. And then you might have another equation for x greater than blank. That would be if it's array, right? So a segment is a two-sided inequality, array is a one-sided inequality, and then these guys over here are the actual equations for the lines. And you could have 2, you could have 3, you could have as many equations as there are pieces. So this is what we mean by the proper piecewise notation. So that's typically how we start. So I will go ahead and do that here in our first example. I'll write it down underneath the graph. So this particular graph is going to have 3 parts, 1, 2, 3. So I need to leave room for 3 equations and 3 domain restrictions. Okay, so I get that started. That's step 1. Use the notation. Okay, step 2 would be to determine the number of pieces. How many pieces does it have? So this one's going to have 3 parts to it. Okay. Then we want to find the domain of each piece. So we look at like the boundary points, the endpoints, and we also ask ourselves if it's a segment or array. So let's take a look at this first piece over here. If I look at the endpoint right here, I can see that it starts at the x value of -6. And then if I look at the other endpoint right here, I can see that that was at the x value of -3. So it looks like my first domain restriction is in between the x values of -6 and -3. Okay, so then that'll be my domain restriction for the first piece. So it's going to be f of x equals blah 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 for x between -6 and -3. Now notice, because I had an open circle on the right side there, then my inequality should not have an equal sign under it. So this inequality has no equal sign because it was an open circle. And then this inequality has a less than or equal to sign because there was a closed circle on the graph at that left endpoint. Also, whenever I'm writing inequalities for segments, right? So this first part is a segment. That's when you have a two-sided inequality. I always write them in the same way. I put the lesser number first. I put a less than sign or a less than or equal to sign. I put x in the middle. I put another less than sign or less than or equal to sign, and then the other number. And I always put the lesser number on the left and the greater number on the right so that the inequalities will make sense. This number will be less than x, which will be less than that number. And that's the case here. -6 is the lowest one, and then these are all the x's in the middle, and then -3 was the higher one. Okay, so that's domain piece number 1. Domain piece number 2 starts at -3 also on the x-axis and goes up to the value of 4 on the x-axis. So this is another segment. Okay, so it's going to start at -3. I'm going to put a less than or equal to sign because it's a closed circle. I'm going to put another less than sign with no equal sign because it's an open circle right here. And then I'm going to put the greater value of 4. So that's referring to this section here from -5 to 4. And so that's this portion of the graph. It goes from -5 until 4. Okay, so that's referring to this domain piece here. And then the last part is array, because it starts right here, and the x value for that is also 4. And then the x values go to the right. So this ray is pointing to the right of 4. So then we would say x is greater than or equal to 4. So when it's array, meaning one-sided, then I always put the x first. And if the ray is to the right of 4, then it would be greater than 4. And if the ray was going the other way, then it would be less than 4. And it's equal to because this is a filled in circle. So greater than or equal to 4. Okay, so we have completed step 3, which was finding the domains of each part. Let me finish with my color coding. Okay, so I'm just color coding the domains here so you can kind of keep track of which is which. So this was the yellow, this one is the pink, and that one is the blue. Okay, so now these parts over here are the equations that would describe those lines. Okay, so that's step 4. Step 4 is writing the equation of each piece by either finding the slope and intercept. So often that's what I will do. I will find slope and y-intercept because that would be the easiest way if it's possible. So that's when you use mx plus b. But sometimes it will not be possible to determine the y-intercept from the graph. So you will have to use point slope form sometimes. And so that's, we'll have to do that at times. Okay, so for this piece here, the one that was between -6 and -3, if I look at it, it looks like it has, if I count rise over run, it looks like it goes up 1, 2, 3, and over 1, 2, 3. Or if you wanted to look piece by piece, it's going up 1 over 1, up 1 over 1. So I can tell with the first piece that the slope is 1 just by counting rise over run. Then if I were to continue counting rise over run, because I notice it has a slope of 1 and I kept going up 1 over 1, up 1 over 1, up 1 over 1, I can see that it would have a y-intercept of 7, right? Because right now on the graph, it's just showing me the part of it that's between -6 and -3. But when I'm writing the equation, I have to consider what the whole line would look like and keep all of that in mind as I'm figuring out my equation. So it looks like the equation for the first piece would be 1x plus 7. So this f of x right here, this is the part where it's y equals, right? So when you're doing y equals mx plus b, the y equals part is this part. F of x equals is the same thing as saying y equals, and then this is the mx plus b part. So the y is going to equal different things at different times. But for these x's, it's equal to that slope and that y-intercept, mx plus b, 1x plus 7. So the first piece is done. Now the second piece is constant, meaning the y value is not changing. The y value is just consistently the same. It's at the y value of 2. And so when that's the case, then the slope is basically 0. And all you have is just your y-intercept. You just have that one single number that y constantly equals, which is 2. So that's your equation, basically. Your equation would just be y equals 2. And again, this part already takes the y equals into consideration. So you don't need to write y equals in here. You just write what y equals. And in this case, it's 2. And then lastly, for this third piece, you would follow the same process of finding the slope and then the y-intercept. So if I look at this line, I can see that it's going down 1 and over 1 from point to point. So I can see that the slope for that line is -1. And then, like the same thing I did with the first piece, I can just continue doing that same rate of change to see where it would hit the y-axis. So if I kept going at a rate of 1 to 1, right? Left 1, up 1, left 1, up 1, left 1, up 1, left 1, up 1, I would get to the y-axis at 10. So this ray is graphing the line that would have hit the y-axis at 10. That would have had a y-intercept of 10. But it's only graphing it for x's greater than or equal to 4. That's why it's starting here. But if you were to graph the whole equation, it would hit the y-axis at 10. And when we're writing these equations here, we have to consider what the full graph would look like, not just the part that we're seeing. So this equation is -1x plus 10. So these here are describing the equations for the full lines. And then these here are indicating the domain restrictions for each piece. And then this whole equation is your answer. So that is what we're basically training you to do, is how can you take a graph that's in pieces and write out its equation using the proper piecewise notation. And this is the process we take. So let's try it again with number 2, because it's good to kind of repeat the steps over and over again so we get better at them. So the first step reminds us to use that proper piecewise notation. This guy right here, the f of x equals the long bracket, the space for the equations, 4, and then the interval for x to tell us where to plot the lines. So I'll start with that. So f of x equals, and then my long skinny bracket. Second part would be to consider how many pieces you have, how many equations. So it's going to have 2 because I have 2 rays. So I'm going to have one here and one here. And then I'm just going to put a little comma. Equation, comma, x interval. Equation, comma, x interval. So sometimes you'll see them written this way. Y equals x plus 7 for x's between -6 and -3. And so on. And sometimes it's written this way where it's just an equation and then comma the x interval. So I wanted to show you both ways. Okay, so the first piece looks like it's a ray that starts at an x value of 1, 2, 3 and points to the left. So if I was to write that as an inequality, since it's a ray, it's just a one-sided inequality. So I'm going to go ahead and start with x. Since it's going to the left of the x value of 3, I'm going to do a less than sign. Since it's an open circle, I'm not going to put an equals. So there's no equals. It's just x is less than 3. So that is a ray. Okay. Now, because we're learning this for the first time, it helps to kind of envision that's the part of the graph that this equation is graphed on. It's graphed for x's that are less than 3. So that's kind of like our little color code. It can be anything in this area. Okay, now the second piece also starts at an x value of 3, right? Because this point is at the same x value, except this ray is going to the right from 3. And this ray has a closed circle. So when I write that inequality, I would write it as greater than 3 because it's moving to the right of 3, and then also equal to 3 because of the closed circle. Okay, so this ray is taking up this half of the grid. So they basically split the grid into two parts, the part that's to the left of 3 and then the part that's to the right of 3. And then this equation that I write here is going to be the equation for this line. And then the equation that I write in this portion will be for this ray here. All right. So I'm going to do the same thing that I did in example 1, where I'm going to use the mx plus b portion, and I'm going to find my slope and my y-intercept when possible. So looking at this ray here, the one that was on the part of the grid that's to the left of 3, I can see from the different points that it's going down 1 and over 1, down 1 over 1, down 1 over 1. So that means it has a slope of -1. Also, this one I can see right on the graph that it hits the y-axis at 4. So that would be my b value from the y equals mx plus b formula. So then I just go ahead and write that equation. M times x plus b, slope times x plus y-intercept, -1x plus 4. And remember, I don't have to use the y equals part in this part of the notation because it's already covered over here. F of x is another name for y. So when you have f of x equals blah, 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 that's the same thing as saying y equals mx plus b. Y equals mx plus b for these x's, and then it's going to equal a different mx plus b for these x's. So now I have to look at this line here. So this line hits the corners every 3 boxes. So it looks like it's going up 1 and over 3, up 1 and over 3, up 1 and over 3. So the second piece looks like it has a slope of 1/3. And if I follow that slope, so if I go down 1 and left 3, I can see that it would hit the y-axis at 3. 1, 2, 3. It would have a y-intercept of 3. Because remember, when you are writing the equation for the ray, you're considering what the whole entire line would do, right? This domain restriction takes care of the fact that I'm only showing this part of it, the part from 3 on, but the equation itself has to envision what the whole line would look like if I continued it. And the whole line would have a y-intercept of 3. So then this equation would be 1/3 x plus 3, mx plus b for the ray, for the part that was greater than or equal to 3. And that is our final answer for number 2. So I have 2 on this sheet that I would like you to try. So I want you to pause the video right here. Like really do that. Like really pause it and try it. Give yourself time. It's probably going to take about 10 minutes. And then continue the video and I will have the solutions ready for you. Like really do it. Like pause it right now and try it. Okay, so I'm hoping you tried both of these and you're just checking your answers now. For number 3, there were 2 pieces. So I have 2 equations and 2 inequalities, and they were both rays, so they're only one-sided inequalities. For this piece right here that was arrowing down to the left, that was for x's that were less than or equal to 1. That line had a slope of 2 and a y-intercept of -1. So that was the first ray. The second ray, that's kind of climbing up here. It's going up to the right. That one had a slope of 1. And if I followed the slope, it would hit the y-axis at 1. So it had a y-intercept of 1. It had an open circle here when x was 1, so that's why that inequality was only for x's strictly greater than 1. So this is the answer for number 3. Then for number 4, there were 3 different parts. You can see the 3 different domain restrictions. There were 2 segments and then 1 ray. For the first segment, it was between the x values of -4 and -1. Whoops, so I actually made a mistake right here. Let me fix that. There we go. Sorry. So between the x's of -4 and 1. And they both had closed circles. So I had less than or equal to signs for both. And because it was a segment, it's a two-sided inequality where I always write the lesser number, less than sign, x, another less than sign, and then the greater number. Okay, and then the middle part was also a segment, and it was between the x values of -1 and 2. Now, just a really quick comment about these inequalities. I just want to point these out to you guys. It doesn't matter which one you put the equal sign under, because it's really hard to tell whether that goes with this part of it or that part of it. But it's important that you don't put an equal sign underneath both, because what would happen then is you'd be saying that there's 2 different y values for the same x, and we're not allowed to do that when we're talking about functions. So if you wanted to, you could have just put a less than sign here and then a less than or equal to sign here. That would have been okay, but it would not have been okay to make both of them less than or equal to. So whenever you have something like this where pieces meet up at a solid point, you can just pick which piece you want to put the equal sign under, but don't put it under both. Okay? So it's just my little comment about that. But the equation for that middle piece was just the constant value of 2, because the y value is just 2 for all of these x's in here, just stayed constant at the y value of 2. So it's just y equals 2. Now the last piece was a ray, so it was just a one-sided inequality. The ray is going to the right of 2, so it was greater than 2. And it had an open circle, so it was not equal to, it was only greater than. The slope of this ray, as you can see, is going up 2 over 1, up 2 over 1. So the m is 2. And then if I continued that process down to the y-axis, I would see that the b value is 4. So that's our final answer for number 4. So basically what I'm going to have you do now when you're done with your video is work on some MyOpen math questions where they've given you the graphs and they want you to find the pieces. Sometimes they just want you to find the pieces and not the domains. And sometimes it's the other way around. They want you to find the domains and not the pieces. And then there's one where they want you to do the whole thing. So I want you to work on that now. The only exception would be if you were absent yesterday and you were taking the PSAT and missed our Match My Desmos challenge. If that's the case, then I want you to do that right now. But if you finish that already, then please work on your MyOpen math assignment. And both of them are due by tomorrow. Also, this material that we just learned right now will not be on your quiz tomorrow. Tomorrow's quiz is only covering skills 1, 2, 4, and 5. And this was skill 6. So skill 6 is not on your quiz tomorrow. This stuff that we did right now will be on your quiz next week. Thank you for tuning in. Be good for the sub, and I'll see you Monday.